Right, moving on to the second half of this paper then. First question here, this is sort of one of these new explanatory questions. First bit there is to do with your properties of odd and even numbers. And the things that you need to know is that if you are adding or subtracting odd and even numbers, let's make a note of it up here for you. Then if you are adding two odd numbers, think 7 and 3, you get 10. I'll give you an even number. Okay? If you add two even numbers, 2 and 6, you get 8. You get even. But if you add an even and an odd together, say 5 and 2, you will get 7, which is odd. So when you add an even and an odd, then you get an odd number. So if you've got three odd numbers here, that means you're doing odd plus odd plus odd. And odd and odd come to even. So if you add those two together, you get an even, which then you're going to add to an odd, an even and an odd, gives you an odd number. So when you add three odd numbers together, you'll always end up with an odd number afterwards. But 50 is even. Even numbers end with 0 or 2, 4, 6 or 8. So that's what they're looking for. Now if you can't remember that, just try it. Take two odd numbers, 5 and 3, add them together, 8, which is even, and repeat that and you'll work out what that pattern is. And there's a similar pattern if you're multiplying these numbers as well. If you're multiplying, then if you multiply two even numbers, like 2 and 4, you get 8, which is even. If you multiply two odd numbers, 7 threes, 21, is odd. And if you multiply an odd times an even, 7 twos, 14, is even. So there's no need to memorize those, just pick examples to work it out yourself. Okay, 11b. If you know what a quarter of a number is, explain how you can find the value of the number. Well, if you know what a quarter of a number is, you know that 4 quarters make a whole. So multiplying it by 4 will give you the whole number. Okay, 4 quarters make a whole. Can't read that as whole, can you? So times by 4. Okay, or you could give an example. Okay, e.g. if a quarter of a number is 5, the number is 5 times 4, 20, because a quarter of 20 is 5. Part C, explain which of 3/10 or 2/5 is the larger. Now when we were looking at the paper 1 questions on fractions, what I was saying there, and the same thing applies here, you can't add or subtract fractions unless the number on the bottom, the denominator, is the same. And it's the same if you're comparing them. It's difficult to say which one is the larger unless they are out of the same thing. So if we take the 2/5 and multiply top and bottom by 2, then it'll turn the bottom into tenths. If I turn the bottom into tenths, I have to turn the top into tenths as well. So 2/5 is the same as 4/10. 4/10 is bigger than 3/10. There's more tenths. Okay, so this is larger. Another way you could have done it, this is a calculator paper, is using your calculator. You got the fraction button in your calculator, 3/10, which you can turn into decimal is 0.3. Okay, so or 3/10 is 0.3. Do the same with 2/5. Fraction button 2/5 equals, change it to decimal, 0.4, and again you can tell there that 0.4 is bigger than 0.3. So either of those methods will do the job for you there. Okay, so that's question 11. It's one of the new things where you've got to explain and show your understanding, but it's only worth 3 marks. If in doubt, try to look for examples to show what you're trying to explain. Okay, question 12. Back to the more traditional style now, which is a pie chart. So it's telling us here that this is out of 240. So we have to divide our 360 degrees in our pie by 240. So 360 divided by 240 is 1.5 degrees. So every person in our survey gets 1.5 degrees. In this part for school, I've got 96 pupils. Okay, so 1.5 degrees per pupil. I have to multiply that by 1.5, and I do the same for each of the others, and that will give me the size of the slice for each part of our pie. So 96 times 1.5, 144 degrees. 64 times 1.5, 96 degrees. 52 times 1.5 is 78 degrees. And 28 times 1.5 is 42 degrees. Okay, now I need to draw my pie. Start off by putting the first line. I tend to go vertically upwards, but you don't have to. You can go anywhere. Then you get your angle measurer. 0, the center of the angle measurer, in the center of the pie, and you line the 0 up with the line that you've just drawn. So my first slice is 144 degrees. You can see that the 10, 20, 30 is the outer scale. Get a reflection of my light. Now that's out. Right, let's calm down a bit. Okay, so we're going to go 144, 10, 20, 30, 40, 90, 120, 130. 140 is there, so 144 will be just there. Use a ruler then to create that second side of the slice, and write in, before you move on, what that slice represents. So that's the school. Now we're going on to college, which is 96 degrees. Now what you do now is you move the 0 to the start of the next slice. Center in the middle, line the 0 up, and we're going now around 96 degrees, which is going to be there. That's college. Job is 78 degrees. Again, spin your angle measure around until the 0 lines up with the start of the next slice. 78 degrees, there's 70. 78 will be there. So that's job, and the one that's left is undecided. So there's your pie chart. That's worth 4 marks. Now we've got some coordinates to deal with. The line PQ is one of the 2 equal sides of an isosceles right-angled triangle. So a right-angled triangle looks like that, and an isosceles right-angled triangle means that that side and that side are the same length. So if that is one side and that's got a length of 1, 2, 3, 4, then it must be 1, 2, 3, 4 that way as well. So that would possibly be one of the right angle triangles. So that has got the coordinate 5, 1. You always do the x coordinate first, across, then up. But my right angle isosceles triangle could look like that. In which case, if that's 4, I've got 1, 2, 3, 4 going that way. So that's another possible point in my right angled isosceles triangle, and that will have the coordinates 5, 5. My isosceles triangle could also look like this. Okay, going this way. So that's another possibility, in which case it will be 1, 2, 3, 4 here, which will be minus 3, 1. And finally, my right angle isosceles could look like this. In which case, the extra point would be there, which has got a coordinate of minus 3, 5. Okay? Don't worry about scribbling things on your paper. Okay? If it helps to draw little sketches, draw them and then transfer that knowledge onto the grid. So there's another 4 marks. So here we are, finally entering the C zone, where anything after this is really going to help us nail the grade C. So probability game of chance, again, these come up very, very regularly and is well worth getting to grips with how these questions work. So here we've got a red bag which contains 3 discs numbered 2, 4 and 6. So red bag 2, 4 and 6, and a blue bag containing 4 discs 1, 3, 5, 7. In a game, a player chooses a disc from each bag and adds the 2 numbers. So that's the rule that gives us what's going on in our table there. So adds the 2 numbers showing on the discs to get the score for the game. For example, if a player on the disc from the red bag is 4 and on the blue bag is 5, the player works out 4 add 5 is 9, and the player scores 9. Complete the following table to show all the possible scores. So if that one's 3 and that one's 2, 3 add 2 is 5. If that one's 5 and that one's 2, 5 add 2 is 7. If that one's 5 and that one's 4, 5 add 4 is 9. That was the example. 3 add 4 is 7, and 7 add 6 is 13. So those numbers inside that box are all the possible scores you could get from playing this game. A player plays the game once. What is the probability of the player scoring 7? So what you do now is you look at your table and find out how many times 7 can occur. And you can see there that 7 can occur on 3 occasions. So the probability will be 3. It's always given as a fraction now, out of the total possible scores, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 possible outcomes, 3 of them are 7, so the probability of scoring a 7 is 3 out of 12. And there you go, we're into the C's. Exchange rates. Gary needs at least £1,200 in euros to go on a trip to Europe. When he goes to the bank, he finds that the lowest euro note that the bank will sell him is the €10 note. The exchange rate is £1 equals 1.16 euros. So every pound he spends, or every pound he has, that's how many euros he can get in exchange. What is the least number of euros that Gary must buy to ensure that he has at least £1,200 worth, and how much did he pay for them? Well, first of all, what we need to do here is to find out how many euros he can actually get for £1,200. So £1,200 times 1.16. Every one of those pounds gets in 1.16 euros. So £1,200 times 1.16 is 1392 euros. Okay, now what makes this question a bit different is that he can't get 1,392 euros because they're only given out in €10 notes. So he's either going to get 1,390 euros or 1,400 euros. If he gets 1,390, he'll end up with less than £1,200 because £1,200 gets him that. So he needs to buy 1,400 euros. Okay, can't get, if he bought 1,390, he would be spending less than £1,200, which is not the condition that we're given. So he needs to buy 1,400 euros. How much are they going to cost him? Well, we have to go backwards now. So to turn from euros into pounds, we divide by the exchange rate of 1.16 to turn that into pounds. So 1,400 divided by 1.16 is 1,206 pounds, and you round that now to 2 decimal places for pence. That would be 90 pence. So £1,206.90. Alright, so they made that quite a complicated question just by the amount of information you've got to get your head around. If in doubt, you know you're going to have to turn that into euros, so just do it, and you're going to get 2 marks for that. Then you're going to get another mark for establishing that you're going to round that up, and then the other 2 marks will be for converting it back into pounds. Okay, angle properties. Find the size of each of the angles marked X, Y and Z in the diagram. Okay, so we can see there that we've got a pair of parallel lines. When we're working with parallel lines, we're looking for Z angles, angles that look like this, where you've got that and that are the same, or you've got your F angles, where that and that would be the same, and so on. So you can see here, there's a Z. It's backwards, but it's the same idea. So if that is 78, my X is 78 as well. This one is your F angle, but it's a backwards F. Nevertheless, it's the same thing. If that's 25, so is that. Okay, so we've got 2 out of the 3 that we need to work out. So we're just going to find out Z now. So let's take a look at what we already know. We know that that's 25. We know that that is 78, but what we've also got here is an F angle there. So if X is 78, that there is 78 too. That means that I've got 2 angles inside a triangle. So I can work out what that angle there is by subtracting those from 180. So we do 180, take away 78, take away 25, that angle there is 77. Now if you've got a pair of intersecting straight lines like that, opposite angles are the same. So if that's 77, that is 77 too. B. Diagram shows a regular 5-sided polygon. Calculate the size of the angle marked B in the diagram. Well, because it's regular, each of these angles around here are the same. So I got 5 equal angles going around a point. You should know that the angles around a point add up to 360. So what you're going to do there is 360 divided by 5 and that will give you the size of each of those angles. (72°). Okay, this is another weird card, another weird question now. Here are 5 cards. Place the cards in the boxes to make the largest result for the product of a 3-digit number. Product means you're multiplying them together. Now what you want to do with a question like this, where you're multiplying, is making sure the card with the largest digit on is in the position with the highest place value. Okay, so you've got that 9 there. Now you're either going to put it there in the hundreds, or you're going to put it there in the tens. If you put it there, it's only going to be multiplied by that large number once. If you do it the other way around, if that was the 9, then that 9 would be multiplied by the largest digit after that, which is 7, and that would be by 9, and that would be by 9. So the largest number is best placed there, and then the second largest number placed there, and then we want the others in descending order. So we're going to have the 4 there, the 3 there, and the 1 there. Okay, what you could do, because you're playing around with a calculator, is you could just try all the different combinations until you find the largest. But that's basically what you need. Is you're either going to work with starting with the 7 there and the 9 there, or the other way around. Whichever way you end up doing it, that's what you'll find out. Question 18 is a multi-stage equation. We've done lots of practice of these. First thing you want to do is to get all the x's together on the left hand side. So we need to get rid of 4x from the right hand side. It's a plus 4x on that side, so we have to do the opposite of plus 4x, which is minus 4x. So we get 6x take away 4x. That plus 20 is on the right side, so that can stay where it is. But this minus 8 we need to get rid of from the left hand side by doing the opposite of take 8, which is add 8. So we get 6x take 4x on this side, and 20 add 8 on that side. 2 and the x are joined by times, so we undo that by dividing by 2. 28 divided by 2 is 14. Now, factorizing is something we haven't done very much practice at all on. Okay, it's the opposite of getting rid of brackets. Okay, what we're going to do here is put these back into brackets, and we do that by taking out anything that's common. Now what I mean by that is that I could write that as 12y, and 36 I can write that as 12 times 3. So the 12 is common to both bits of that algebraic expression. It's in the 12, and if I take it out of the 12, I'm left with y. If I take it out of the 36, I'm left with 3. And I can check that by doing what we're more familiar with, which is by multiplying out the brackets. 12 times y is 12y, 12 times 3 is 36. So that's factorizing. Looking to see what number goes into both parts of the expression and taking it out. Question 19. Let's take a look at what this question is. In 2007, the cost of heating Mr. Oak's house was £762.50. At the start of 2008, Mr. Oak spent £300 on improving the insulation of his house. Mr. Oak found that his heating bill in 2008 was 20% less than in 2007, and that his heating bill for 2009 was 20% less than in 2008. So it's a compound percentage question. Find the cost of Mr. Oak's heating bill for 2009. So at the start of 2007, that's how much his heating bill was. At the start of 2008, it was 20% less than in 2007. So first of all, we need to work out what 20% of £762.50 is. Okay, and we do that by writing 20% as a decimal times £762.50. So that's £152.50. So in 2008, his bill was, that's how much it was in 2007, and it was that much less. So £762.50, £152.50, £610. And then in 2009, it was 20% less than in 2008. So now we're going to do 20% times 610, which is £122. So in 2009, his bill was, it was 610 less £122. £488. Okay, so that's the cost in 2009. Let me just talk you through that again. In 2007, his heating bill was £762.50. In 2008, it was 20% less than the previous year. So 20% of £762.50 is £152.50. That's how much less it was going to be. So that's how much he saved. His bill in 2008 was going to be £610. Then the following year it was 20% less again. So we find out what 20% of 610 is, £122. So in 2009, it's the cost of the previous year less another £122, £488. Part B. Was it worth Mr. Oak spending £300 on improving the insulation in his house? You must give a reason for your answer. Well, it cost him £300 in order to insulate his house. So if the saving he's made is around the £300 mark, and he can carry on making that saving, then that will be worthwhile. So the total saving so far will be £762.50. That's what his bill was, less what he was paying in 2009, which comes to £274.50. Okay, which is less than the £300 that it cost him to improve the insulation. So this is less than the £300 it cost to insulate. But if he makes another 20% the following year, then it is going to be worth his while. So if savings continue, it will be worthwhile. Okay, so just clarify that again. He spent £300 on the improvement. Over the 2 years that he's had it, he has saved £274.50. So he hasn't made his money back. But if he keeps saving 20%, then it will have paid off. Okay, last couple of questions. Question 20, hopefully you recognize this now. We got a right angle triangle. We know two sides. We're trying to find the third. So it's Pythagoras. What I said to you, don't worry about anything else. First of all, square what you're given. As soon as you see a right angle triangle and you know two of the sides, square them and you're in business. So 3.4. On your calculator, you've got a squared button, which is there. 11.56, or you can just type in 3.4 times 3.4. 7.1 squared. 50.41. Right, so we've done the squaring. Now what we have to decide is, are we going to add those or subtract them? And the decision you have to make is, are you trying to find the longest side or one of the others? What I said when we did this in class was that this is an arrow that points to the longest side. So this is my longest side. There's my arrow. I'm trying to find it. If I'm trying to find the longest side, I add my squares. So I'm going to do 11.56 plus 50.41. So that's 61.97. That gives me the size of the square along there. I don't want to work with squares now. I want to find out what the original is. So I have to square root my 61.97. There's the square root button. 61.97 equals, so that's going to be 7 point. And if I give it a one decimal place, it's either going to be 7.8 or 7.9. You look at the next one along, it's 5 or bigger, so that rounds up to 7.921 dp. Okay, so it's going to come up almost certainly on a paper 2 where you're allowed to use a calculator. It's going to be clearly a right angle, and you're going to know two of the sides. Square the sides, then decide, are you going to add them or subtract them? If you're trying to find the longest side, which is pointed to by the right angle box, you add them. If you know that side, then you subtract the squares that you know. Once you finish working with the squares, you square root in order to find the side that you don't know. And the last question here is one that very rarely comes up on past papers. It's an inequality. Treat the inequality as if it was an equal sign. So the rules of algebra, certainly on the foundation to your paper, it's just exactly the same as if that was an equal sign and it's an equation. So we want to get all our n's, all our unknowns on the left hand side. That 2n there is a plus 2n because there's no symbol in front of it. So in order to undo it, I've got to subtract 2n. Got to do that on both sides. So 6n subtract 2n, that leaves me the plus 11 on its own on the other side. 6n take away 2n is 4n. Then I want to get the n on its own. So the n on its own is joined by times by 4. So I have to divide by 4. So you get n, and what that symbol means is less than. So n is less than 11 quarters. But if you just work out what 11 quarters would give you as a decimal, that's 2.75. So that is saying that n must be smaller than 2.75. Part B, write down the largest integer. Now, integer means whole number. Write down the largest whole number value of n that satisfies this inequality. So n has to be smaller than 2.75 and be a whole number. So the smallest whole number, if you think of your number line, okay, you got 0, 1, 2, 3, 4, etc., etc., etc. 2.75 is there. The whole number nearest but less than that is going to be 2. So 2 is that final answer there. But in all honesty, that question 21 is really there for the higher tier paper where you've got the overlap. Okay, so if you manage to follow that, superb. Basically, as far as we're concerned in the foundation tier, treat that inequality there in exactly the same way as if it was an equal sign and you were solving an equation. The same rules of algebra apply. But if you've got lots of the things right before that and you're well into your grade C, that's not worth losing sleep over.